Hi everyone, how are you doing? I believe you're doing fine. Today we are going to continue on electrolysis, but today I'll be talking basically on the Faraday's second law of electrolysis. Now, let's take the Faraday's second law of electrolysis first. Faraday's second law of electrolysis states that when the same quantity of electricity pass through different electrolytes, the relative number of moles of the element's discharge is inversely proportional to the charges on the ion of the element. Remember, I want you to pick one thing here, the same quantity. Same quantity. I want you to pick that because most of the questions that are asked under the second Faraday law of electrolysis are always with same quantity. So that is why I told you to pick that same quantity. So whenever you see a question that talk about same quantity of electrolysis of this, know that they are talking about the second Faraday of electrolysis or Faraday's second law of electrolysis. So let's look at let's derive an equation for this Faraday's second law of electrolysis and also solve some questions under it. Now let's go on. Now remember, let's quickly go back to another formula I gave you in our last class, which is your M equals to relative atomic mass. You still remember? Multiplied by Q. Do you still remember? All over number of charges times Faraday constant. Now from here, we can make our Q the subject of the formula here by doing what? By dividing. Now from here, we can make Q the subject of the formula. How do we do that? When you cross multiply, we have RAM, right? Multiplied by Q equals to M, which is your mass, multiplied by number of charges, multiplied by F. Do you still remember? Now from here, we can divide through by relative atomic mass. When you divide through by relative atomic mass, what do we have? Relative atomic mass cancel relative atomic mass here. So eventually we have our Q to be equals to mass times number of charges times Faraday constant all over relative atomic mass. Now let's quickly go back to mole concept. You remember your number of moles equals to mass over molar mass. You still remember? Now from here, look at it. This is my mass and this is my relative atomic mass, which is the same thing as my molar mass. So I can input my number of moles, which is mass over molar mass, to this equation. Now if I input my number of moles to this equation, it's going to give you Q equals to, let's say capital letter M for number of moles multiplied by number of charges multiplied by Faraday constant. Now this is a new equation for our for electrolysis. Now let me quickly write the parameters down. Q stands for quantity of electricity. Then we have N, number of charges. We also have F, Faraday constant. We have what else? We have M, capital letter M, which is what? Number of moles. Now let's solve some questions under this. Now let's look at the question together. What quantity of copper will be deposited by the same quantity of electricity that deposited 9.0 gram of aluminium? You are given the molar mass of aluminium to be 27 and copper to be 64. Now here, I want you to pick out something. Remember I told you that wherever you see same quantity, they are talking about this Faraday's second law of electrolysis. Now look at it here. This is same quantity, which shows that it is second Faraday or Faraday's second law of electrolysis. Now let's work it out. Now the first thing we're going to do is write out the parameters. What are we given? We're given mass of aluminium, right, to be 9.0 gram. We are also given molar mass of aluminium to be 27. We are given molar mass of copper to be 64. That's all. Now, we will have to calculate mass of copper here. So mass of copper here is what we are looking for. But before you can get mass of copper, you must calculate for the quantity of electricity of aluminium. Now, how do we do that? Let's quickly go back to our formula. Our formula of mass equals to relative atomic mass multiplied by Q. Remember, all over number of charges times Faraday constant. Do you still remember this? Now, from here, if you make Q the subject of the formula here, what do we have? We have Q to be equals to mass times number of charges times Faraday constant, right? All over relative atomic mass. Now, let's input it. We have Q. Remember, we are calculating for aluminium. We have Q to be equal to, what is the mass number of aluminium here? 9.0 multiplied by, what is the number of charges? The number of charges, aluminium always carry 3 plus, so the number of charges there is 3. Multiplied by 3 times, what is our Faraday constant? It is always given, it is constant, it is 96500 coulombs. So multiplied by 96500 coulombs all over, what is the relative atomic mass or molar mass of aluminium? 27. So what will be our Q now? Our Q will be what? 9 times 3 here is 27, right? And this is 27. So we can say, or better still, 9 here, 1, 9 here, 3, right? 3 here, 1, 3 here, 1, right? So eventually, our quantity of electricity is 96500 coulombs. So we've calculated for the quantity of electricity of aluminium. Now let's now go back. Remember, we are looking for mass of copper, not quantity of aluminium. Now let's now go back and look for mass of copper now. Now, in order to calculate mass of copper, let's quickly go back to the question again. They said, what quantity of copper will be deposited by the same quantity of electricity that deposited 9.0 gram of aluminium? So, which means that the quantity of electricity that deposited 9.0 gram of aluminium is 96500. So, this quantity of electricity will also be the same quantity of electricity that will deposit copper. So, in other words, we are going to also use the quantity of aluminium here, the quantity of electricity of aluminium here, to calculate for the quantity, or to replace the quantity of electricity of copper. What do I mean by that? Let's go back to this formula. Mass equals to relative atomic mass, right? Multiplied by Q all over number of charges times Faraday constant. So here now, mass of copper will be equal to, what is the relative atomic mass of copper? 64, right? Multiplied by quantity of electricity of copper. We are going to make use of that of aluminium because they have said it here that the copper will also make use of the quantity of that of aluminium. So we are going to make use of 96500 that we got here all over number of charges. What is the number of charges of copper? Copper always carries 2 plus. So the number of charges there is 2 times Faraday constant, which is 96500. So here now, what do we have? 96500 here, cancel 96500 here. Our hem will now be equals to 2 here, 1, 2 here, 32. Our hem here will now be equals to 32 gram. And that is our answer. I hope it is clear. But let's try another question. Then after that question, I'm going to give you a question to work on. And remember, always send your answer under the comment section. So let's look at number 2 question. Question number 2 says, how many moles of copper will be deposited by passing 3 Faraday of electricity through a solution of copper sulfate? Now, solution. Okay. What we are given, I told you to always write out your parameter. The parameters we are given here is the quantity of electricity. And the quantity of electricity here is 3 Faraday, which is the same thing as 3 times 9, 3 times 96500. You know 1 Faraday is 96500. So 3 times 96500 will give us what? Let's press our calculator for that. So when you press the calculator, what you get is 289,500 coulombs. That is our quantity of electricity. So what else are we giving? We're not giving anything. Then we will have to calculate for moles. Now remember the formula that contains number of moles. Your Q equals to number of moles multiplied by number of charges multiplied by Faraday constant. Remember this formula? That is what we are going to use because it's the only one that contains number of moles. Now, we are going to make our number of moles the subject of the formula now. When you make your number of moles the subject of the formula, what you have is M equals to Q over N multiplied by F. So this is the formula we are using to do our calculation. This is the formula we are using. Now, our number of moles will now be equal to, what is our Q? Our Q is 289,500 coulombs all over number of charges. Remember, copper sulfate, when it breaks down or dissociates, we have copper 2 plus SO4 2 minus. So the number of charges of copper is 2. So it's going to be 2 multiplied by what is Faraday constant. I always told you that that one is a figure that is constant, which is 96500, and it will always be given to you. So 96500. So what do we do next? Let's cut this one 1, this one 3, right? So our answer is what? 3 over 2, which is the same thing as 1.5 moles. So our answer is 1.5. I hope it's clear. Now it's time to give you a question to solve. And when you solve that question, don't forget to send your answer under the comment section. So let's look at the question together. This is the question that you're going to be solving for me. I will be expecting your answer under the comment section. See you in the next video. Bye.